Let's get going here. So thank you everybody for joining us for our midterm fall 2016 TWed. Tonight we actually have a talk that was an example of the original intent of TWed when we started this almost 6 years ago, which is a talk about a new technology developed in the lab, developed here at Tabular's World. So Jim McCusker, who created SETLr and the associated tools, and Katie Chastain, the alpha user, or beta users, I guess Jim himself is the alpha user, are going to lead us in a kind of a tutorial session, kind of an explanation of why SETLr exists and what it's useful for, where and what direction it's going to go. Jim will be talking remotely, and Katie's going to be here playing Vanna White. Katie's got the slides. Just a reminder, as with almost all TWeds, this is being streamed live. It's being recorded. And today it's going to be special because we're going to try to be juggling between our screen, video, whatever. And so without further ado, kick it off. Thank you, Katie. And Jim.
Hi. So, so SETLr is, SETLr stands for the Semantic Extraction, extract, transform, and load-er. The is slightly abbreviated. So SETLr came about because of basically I'd become frustrated with kind of the mode of use of an existing semantic interpretation tool. I'm going to call these things semantic interpretation tools. These CSV.rdf for LOD, and also another tool, the Google Refine RDF plugin. So I was frustrated with each of these for different reasons, but the main thing was that the Google Refine RDF tool was very easy to use, but it was very hard to automate. The CSV RDF tool was very easy to automate, but very hard to use. And this was especially true when I was attempting to build ontologies. Blank nodes in CSV to RDF are actually hard to build, and I think that might have been slightly on purpose. But unfortunately, in ontologies, blank nodes are everywhere. There are also other issues that I'll be talking about as we go through this. But basically, it was a rethink of the semantic interpretation task using tools that have kind of come into being since the beginning of CSV to RDF, and kind of how can we put these together to build that. So I just realized I tried to change slides and it's not going to work. Oh, okay. So right. So so we're going to talk a little bit about SETLr. I already did a little bit, but also we're also going to give you a short tutorial about SETLr, and then we'll take any questions and have some discussions, and hopefully talk about what my plans for SETLr are as well, which we don't have slides for, but I could just yammer on. Next. Okay, so the semantic interpretation is valuable for a number of reasons. One is that we actually have a number of semantic web applications that we are in the process of building at TWed for many different projects. And actually, one of my core research ideas is this idea that when you look at data in a semantic representation that's tied in with ontologies and underlying knowledge, you can actually do a lot more with that data than you could in kind of a base representation where you just have it in a spreadsheet or a R data frame or something like that. And part of that has to do with being able to expand and annotate the data, has to do with being able to find the data that you're interested in very quickly, and how you can scale up that data and still do kind of broad-reaching graph searches to pull in the pieces that are relevant to you. And it's also reusable because you're actually building off of other people's semantics about how data is represented. So if I have a document collection, we want to be able, like of a collection of papers, it's really easy to align that with the Dublin Core terms and Bebo to provide a repository that basically everyone can understand without having to try to figure out what the columns in my spreadsheet mean. But the problem is that basically adding semantic interpretations is hard, and it can be made harder by the fact that the representations that we're trying to build in the data can be fairly complex. If you have, just to stick with this example of a paper, I mean, you don't just have a paper and then you have fields off the paper. You have a paper, you have a number of authors, you have a publisher, you have a journal or proceedings, you have the location where that is, you have issues, you have basically all of these things. These aren't just fields, text fields, but these are actual things that at one level or another you might want to represent. And to simply say this is one object in this row and it's got a bunch of fields on it usually is insufficient. But kind of going beyond that in your data representation can be very hard, and a lot of semantic interpretation tools, because that is kind of the trivial base case, they make that easy and they make the harder stuff hard. And so I've been looking for a long time about how we can take basically make the reasonably complicated things easy as well, so that you can build kind of the graph, the RDF graphs that really truly represent the data that you are trying to interpret, rather than trying to approximate it. Okay, next. Okay, so CSV to RDF for LOD is a classic tool that's come out of Tetherless World and was actually originally developed as a way to more efficiently and cleanly.
Jim, you just got distant.
Oh, I did.
I think it might be the fading battery that
Hello?
you mentioned earlier. And I think that might be why he ran upstairs.
Oh, okay.
What happened? Am I still distant?
Jim, nothing changed on your end because all of a sudden you got lower volume.
Am I still
It's
low volume?
a problem with the speaker on our end, and I think John was.
Okay. Am I still quiet?
Yeah,
Fade away.
I know.
I literally have my face over the keyboard. Hello?
Yeah, we got you back.
Okay. This is that's better? Am I still okay?
That low sounded good.
Is that better?
Jim, are you still talking?
I'm still talking.
Yeah, go off mute and just tell them that we're just having some.
I can hear you fine. All of everything that's that John is saying is going on over the air. So.
Why would you? Why would you want to go backwards?
CSV files of their input.
Jimmy, you there?
Yes,
Try
I'm
talking.
talking something.
Okay, we'll have to do it this way.
Okay.
But just have to push it up to,
Uh-oh.
yeah. Okay, let's try this.
I need to
Okay,
realize.
go for it. That's the best we'll do for a second.
Okay. Is that any better?
Yeah, just go ahead, Jim. We've got some issues, but we can hear you.
Okay, great.
Fine, go ahead.
Okay, so CSV to RDF for LOD is a classic framework tool that has come out of the Tetherless World Lab by Tim Lebo that we've used in a number of Tetherless projects, including the world famous LogD project. At least it's world famous in Troy. That is basically has converted billions of or triples, billions of triples from CSV files and similar things that come from open government data sets. Now, one of the limitations of CSV to RDF is that so actually no, let's talk about the advantages. So the enhancement parameters are stored in Turtle. So the nice thing is you can actually use those parameters to preserve provenance about how it was converted. It has a wide variety of conversion options, although a lot of the conversion approaches are kind of standalone and sometimes require flattening of the data that you have. So for instance, you have a JSON or an XML file, JSON file or an XML file. It requires you to flatten it out to a tabular form before processing. But basically, the base use case is to convert a CSV file into RDF. It does so. It can do a naive transformation of that, or it can do what's called an enhanced transformation of it to produce more complex RDF. It is declarative, and the language for defining that has, in some ways, it's gotten a little mature in some ways. So it's really good at the use cases that it was designed for, but it is not. I found it easy to come up against limitations in its approach, and especially around having multiple objects in a conversion or a given row. But yeah, so it's useful, and it's industrial grade, really easy to automate, and I've been using it for years. But we're trying to move beyond it and come up with a rethink of the approach. Okay, next. And the other option is SETLr, which, as I said, stands for Semantic Extract, Transform, and Loader. Essentially, we are combining best-of-breed technologies and standards to easily generate RDF from a number of data sources, one of which is, or kind of, the most common use case is tabular data, but we support non-tabular data as well. And we support a variety of input and output formats. For instance, one input format that, in addition to tabular and RDF and tabular and XML and JSON, we support some more obscure things like the SAS dataset formats that are used, and basically we have the ability to quickly add anything that's supported by the pandas framework to generate data frames for processing. And we support any output format that's supported by RDF-lib. And we pull together basically a JSON-LD-based templating language with a Prav-based workflow et.al language to perform transformations and to show how these extractions and transformations and loadings are supposed to fit together. Okay, next. Right. So this is the SETLr architecture as hastily sketched by me. Basically, extract means to pull information from a input data source. In this case, these are the formats that we currently support: JSON, XML, Excel, SAS, CSV, and a couple others like that. And actually, CSV variants like tab separated value, and you can actually indicate what delimiter you use and so forth. And actually, you can also use RDF as an input format as well, as long as you know how to iterate over the objects in it. That's extracted into a in-memory representation that the JSON-LD templating language, JSON-LDT, basically processes and transforms into an RDF graph, which is then loaded into a RDF on disk or loaded to a Sparkle endpoint, Sparkle update endpoint. The JSON-LD templating language is built on basically it's JSON-LD plus. It's a superset of the JSON-LD language, which includes basically templating within all the text areas. So if you put something in quotes, it's actually being processed through the Jinja templating language, which means you can embed curly braces and access variables in there. You can do this on in IDs. You could do this in types. You could do this in predicates. You could do this in graph IDs. You could do this in the values. And also there's we use Python expressions to evaluate the instances for loops and branches. So there's @if, which will determine whether or not a given entity is used. There's included @for and @do to come up with a loop of things or a list of things to loop over, and the do is the fragment that actually shows up. And basically, all of this rounds out to stuff that already exists. So it was nice because JSON-LD itself is a very powerful way to express data. That in some ways is even, when you're templating it, is more powerful than trying to template Turtle or XML. And you'll see why in a minute or two. But basically, the idea is that there are advantages to how we put this stuff together that go beyond just immediate use cases. So I've been able to do things with SETLr that I didn't expect to be able to do when I set out to do this, because I was able to basically take something, to be creative about how I'm expressing the transformation or the interpretation based on the language that I've built. So it's a very expressive language for interpreting data into RDF. Next. Okay. So Katie, do you want to take it from here? And I'll interject as needed.
Okay. This is sort of like what the extract portion of SETLr script would look like. It means prob to describe the activities performed and preserve provenance, so you have that available to you as well. You can extract multiple files. This is how you extract one of them. And this particular example is for a CSV table. It will look slightly different depending on for the other formats, and that's detailed on the wiki page. And we have a list, like Jim was saying, of various input types we support.
And one thing to note the social.csv file, that's a valid URI, but it's relative to the current working directory. But when you run SETLr with this, you will look in the current directory for that CSV file.
Yeah, you were a little bit muddled.
Sorry.
Well, what Jim said, and this is a great point, is this is a valid URL. You know, this is what we would expect normally if it's in angle brackets. That would be a URL, and that's what it is. But the assumption is this is in local directory.
Right. That you can have basically there are a number of resolvers that are used, but basically you can load files off of disk, or you can also load files off of the web just as easily. In fact, we take advantage of that in a number of projects.
Spreadsheet, you can plug the Google spreadsheet link in there with the export format as CSV specified, that you can put that into the URL. And just put that in the prod use. This is.
So actually, could you go back just for a quick? So if I was a dum-dum and I used the file : / format for doing that a local file, would that have worked also?
Yes.
Okay, cool.
That's not being a dum-dum, that's being clever.
So on a similar note, any absolute path would work?
Yes, exactly. Yeah, it defaults to assuming a file URI, but yes, a absolute path, either using the file URI or using just a bare URL, a bare path will work the same. And it could be absolute, it could be relative. It doesn't matter.
I guess also another thing to note here is you have this CSVW delimiters comma here. You can set it to tag for a tag separate value or specify other delimiters as needed.
But it's still the CSVW.
That's yeah.
CSVW is a vocabulary called CSV on the web, and it includes specifications for things like what delimiter to use, what quote escaping to use, and things like that. I think we're interpreting things where it makes sense, but there's a whole bunch of those. And if you need something and it doesn't work, let me know and I'll make it work.
Yeah, you need to be reading this as RDF. It's a table, it's a SETLr table, it has this delimiter.
Right. And the
Brackets or this one. Okay.
yeah, the wiki page has the types for kind of the non-text delimited formats like export, SAS, and Excel, but it's fairly straightforward.
Alright, so the next thing we want to do is transform the data. So we're defining our data set object. We're just calling it example.com/social. And it's a void data set, and it was generated by a SETL transform and settled JSON-LD template. So it's using the JSON-LD template that we were talking about. And it used the table entity that we created from the extract step before. So, and it has used the has context to specify context like you would in JSON-LD. It provides the context for all of the JSON-LD generated by the template. You can also use Jinja template filters on the output text as you integrate that in. You can see that's like sort of the first half of this example. When you actually process the table here, the prompt value of the transformation is the transformation itself. So here you have the ID is you're minting a new URI for each row in the table, and the end part of the URI is the ID column from the row that you're processing. In this example, you give it a type of faux person, you can template that if you'd like. And we have a faux name that's from the name column from the row.
And one nice thing, so one thing to note here is that basically an RDF graph is created for every row in the table. And that RDF graph is parsed from whatever is in this template. So we generate a JSON-LD tree, which gets realized to string, which then gets parsed to RDF, and then that gets appended to the existing graph.
Could you similarly call column dot?
No, it goes row by row.
Yeah, that one, usually when you're doing your RDF conversion, you're going, it's basically subject, predicate, object is the way you think about it, the
Yeah.
rectangular conversion.
Right. And actually, there's a way to iterate over the columns in this as well, because we'll talk about that in the for loop. Although I don't know if Katie put that example in. There's a kind of a quick transformation to assume that the columns, so each one is an entity in each column of property.
Oh, yeah, I knew that one. I did not put that in, sorry.
Okay. I can show that potentially in the wiki if people are interested.
And then for the final step, we load. So we find the social.ttl, which is our resulting converted data. It's a file. Here we specify DC terms format as text turtle. You would change the DC terms format depending on what output format you want. And it's generated by SETL load, and it uses the URI of the graph that we defined in the previous step. So there's, again, the list of output formats. And you can also give the format as SD service from the Sparkle service description language vocabulary, and use that to also load directly into a Sparkle endpoint.
Okay. So that's not 100% right. The load, the thing that's generated by the load is supposed to be is of type SD service. Not terms format. But that's a good point.
But essentially, after the transform will process each row of the table together, maybe it's a little RDF graph, aggregating them all together, and working in this way. So, tutorial part.
Wait, could you just go back? I'm sorry to be. So so Jim, you're just keep in mind you're not on the big speaker. You're coming through my laptop, which is turned up to 11.
Okay.
But the point that you were making, and as a follow-up to what Katie said, is that it is. I think you said it's actually a load is of type SD service. That's
well,
how you.
Here, where you have social.ttl, a PV file, you would instead say social.ttl, or whatever you want to call it, a SD service.
Ah, right. Okay.
Okay.
Right there. So what you're sort of doing by directing it here, you're saying in what she's got up here, you're saying this turtle file is a file, where previously we said we were directing it to this, whereas you're saying to have it sent to the service, it would be, you're just saying that turtle file is a service.
Okay.
Is that correct?
Yes.
Okay.
And you wouldn't call it a turtle file either, but that's okay.
Well, okay, so yeah, so how did we get that? Okay, I get it. What would you call it?
Well, you can name it whatever you like. It's just a resource. The SD endpoint, I think, is the thing that matters.
Okay.
You load directly onto a website or like a URL, for example, example.com. If you have that domain, could you use SETLr to load?
It won't do DAV yet, but that is one of the goals. That would make it so that it supports the linked data platform. We don't have that yet, but that is something that as soon as we have someone who wants it, we'll try that out.
So, Jim, I'm sorry to be anal on this, but so you're saying that you have a URL which is the endpoint, you would declare the endpoint with the SD endpoint, and also you would say that that's the service.
Yeah, you say it's a service, and then you give it the SD endpoint, and the endpoint URL is what's actually being used to update. So whatever URI you use for the SD service itself is just a local thing for reference. It's not going to be used to actually access it.
Right. Okay. Cool.
Because that's how that's how the Sparkle service description works, and it's a little annoying. But I wanted to stay in line with them.
I can't imagine, W3C standard being annoying. I can't imagine it introducing multiple levels of indirection.
Whereas the author of a couple.
Yeah, that's right.
Why would they do that?
The co-author of the infamous what did we call it? The in DCAT, I can't remember. Anyways, go ahead.
Right.
Okay.
What an exciting tutorial time.
Okay.
So if you want to follow along, or we also have this available. This is the tutorials given on the wiki page for SETLr. Basically, step one is clone the repository. And it's the title world /SETLr, so it's an extra short URL, fortunately. And then you just change directory and you can set up a virtual environment. It's not required, but we recommend doing the virtual environment if you have that available. So you start up your VMD and then click install and then -e and dot. And that should take care of downloading all the dependencies and get everything set up for you to settle.
So there's no dependencies that you have to get in place ahead of time.
Well, except for Python and virtual env.
Except Python and what?
Virtual env. So if your Python distribution doesn't come with virtual env and pip automatically, you'll need to install those.
And it's Python 2 dot whatever?
Yeah, it's Python 2.7 is the ideal one.
Okay. So
I think,
the normal person's current Python.
exactly.
As opposed to Python 3, which is
It's like Netscape 5.
so it might be easier if you're trying to follow along, just Google on SETLr.
Yeah.
And
Yeah,
it's
one of the steps on the wiki as well.
Yeah.
The setup steps is on the README and the HBGDki repository, and then if you just want to click over to the wiki and the SETLr tutorial, then you can like copy paste and stuff. It'll be a lot easier if you try to copy it here.
I caught up.
Okay. Here's our sample data. It's provided on the wiki page if you want to copy and paste that into a CSV file and just save it as social.csv. No, social data.
Oh, yeah, so that's just going to help you keep track for reference what we're doing.
So a couple things to pay attention to for those watching at home.
It's going to have to figure out how to parse the values in this column. It's going to have to deal with the typing of the stuff in this column.
And also, like blank.
It's going to have to deal with blanks.
Ready? Accept.
Go ahead, they can.
So SETLr file is internal. You can call yours social.setl.ttl. And you can define the prefixes defined at the beginning. This is for the conversion portion. includes copycat use terms, void for a lot of the prominent stuff, and some of the subtle vocabulary.
Are these the standard? This is sort of the standard set of prefixes to include?
Yeah, you're going to need these at least, yeah. So just add them to make your life easier. Sorry.
And the last one is your default for this example.
Yeah, exactly.
Alright, so first comes the extract part. Like we were talking before, you generate a single table entity generated by an extract activity on your social.csv file.
This is just what we saw before.
Yep.
Yeah, I think we don't need to keep it up for that one. I think that we can, if people want to actually follow along with the
We didn't quite get that, Jim, but
I said if people want to follow along, they can see the stuff on the wiki page rather than trying to copy it down.
yeah, I think the people that are following along are following the wiki page. Yeah.
Alright, so for the first part of the transform, we're defining a data set and it's generated by the transform activity. We're using, for SETL has context. Within the data that we're converting, we want to use the brand-book brand ontology, and so you define the faux prefix in the has context section here. So that's for within your transformation. And then the prod value of the transformation is what we're doing to the data. So this is sort of like a preliminary transformation that only utilizes the first two columns, the ID and the name. You can also, if you want to use the try out the Jinja templates in the values, you can say something like row ID and then pipe shift and upper, and that would change the value of that string to all uppercase. There's a variety of different things that you can do with that lowercase, kind of with other formatting.
You can do math. You can do most Python-like expressions in there, and you can access any information off of the objects within that.
Then at the very end, you give your output file name and specify the format. So for the example, the output is turtle. And we just call it social.turtle.
Okay.
And then when you're ready, you run it, you command SETLr, and then you of your settle file. And if you run it with sample at the end, it will only process the first 10 rows, which is super handy if you are working out what you're trying to do with your template and you want to test it, but you don't want to convert the entire bajillion rows of whatever spreadsheet you're working with. So that just gives you a small sample of the data so you can, for error checking. Sphere.
So I put a void data set stuff into the kernel file.
Mm-hmm.
So, how it works.
Could you go back a couple, just review. So go back to the beginning, just review. Yeah. So that's your extract. That's cool. Okay. Yeah. And then go on to the next, and it's the.
That's cool.
This is where it's actually getting interesting. And this is actually a two-parter. This and the next one completes that first square bracket.
Mm-hmm.
Okay. Just want to wait. Don't go back. I want to actually see it. So it's okay. So.
So all this stuff goes in the same file,
Yeah, it's all the same.
and you put in the stuff after this?
Yeah, it's all one file. This is the equivalent of like a your EPRAMs, yeah.
And the load part, the left part, and then you're on the Do I need the app prefix SD part at the endpoint part?
Um,
Oh, don't do it endpoint.
not the endpoint part.
Oh,
I mean, you just get a turtle file out, yeah.
So, yeah, it's just-
Turtle file is where it should be.
It should come in the same directory.
And I'm in the beacon as well.
So there's a lot to like here. Well, I mean, what's really nice is that you're doing it very locally. You know, that we're all familiar with the dashboard. You know, that mode of, you know, that the whole set of that the whole file hierarchy that you've got to set up and get right for CSV to RDF. And then where it puts things, and the different places it puts things, all that kind of stuff. And
And then which one to go back and edit.
right, exactly, where do you edit, and what it's going to do next Tuesday and all that kind of stuff. So it's really nice that this is local. What's different is that this is you're specifying the behavior of the columns. More using sort of a program kind of a thing. The thing that CSV to RDF does is it sort of does that initial processing, that raw processing, and generates the parameters, which you then dive in and say, okay, this column I'm going to make be this, and this column I'm going to be this, and so you're configuring using RDF to kind of configure RDF, which you're sort of doing here too. It's just a totally different way.
Yeah. So and actually, the JSON-LD is kind of embedding an RDF template inside of RDF, which
Yeah.
could be a little mind-bending. But actually, so two things to note. One is that it could be perfectly possible to create an initial conversion file the way CSV to RDF does. We just haven't done that yet.
Yeah, that question came to my mind, but I decided not to say it.
Right. The other thing is that SETLr could theoretically run within the CSV to RDF conversion automation framework. So you know, like the directories and the source and version and all that stuff can use SETLr as a conversion tool. And Tim has said many times that the CSV to RDF conversion tool is just one way to do conversion within the automation framework.
Yeah. Well, yeah, that's a very good point. That the actual it's a framework. CSV to RDF for LOD is a framework. It's a whole stack of scripts. The dilithium crystal, the whole thing is a Java program, which is the actual converter. The other thing to note, it just occurred to me, is that was created around 7 years ago when he started that. The actual Java code, and then the scripts kind of have grown up. All right.
The other thing to note is that the architecture of the SETL script. So JSON-LD is, to turn this around, JSON-LD is one transformation method that is currently registered into SETLr, but it's certainly possible to add others. And so the plan actually is to add, so I actually had something in there that did Sparkle update based transformations, although I kind of, that's been kind of sitting aside because it was surprisingly slow. But there's lots of other things that could be plugged in, and theoretically you could plug in the CSV to RDF converter in as a transformation method.
So Jim, this is kind of, I think, well, I don't know if this is a related question or not. How do you do something like what what Tim called I think it was called a links via. I don't know if it's still called a links via, but where you're essentially doing a little query to like draw in. So as you're processing, let's say you want to look up in a instance hub a URI for a name or a URI for something.
Mhm.
You've got that cell value, it's the thing, and now you want to use that thing as the basis. You actually want to slip in a URI, so you're going to shout out to an instance hub to do a query and find it.
Right. So right now you can't do API calls from within here, although it would be beneficial to add that.
Yeah.
Conversely, there's actually a way to use secondary data sources that we will get to in here. So if you have another table that has those mappings somewhere,
Yeah.
you look up in that table.
Yeah, Katie is fervently nodding her head. So
What I'm doing right now with the HBGDki data, we've got an auxiliary table that has the mappings available and also has some other information. I've got a whole bunch of Python and control flow shenanigans going on to pull information from that auxiliary sheet as well as the actual file, the JSON file that we're working on converting right now.
yeah, that's huge because that's important both for ontology generation, which, as Jim said, is one of the big motivators for using this framework, but also when you've got data that you're bringing in that has equivalent, has entity identifiers that you need to recover.
Yeah, and actually the other thing is that you can actually just load RDF graphs and then do Sparkle queries against those graphs to resolve things.
Well, there's that too.
And those actually, I think those at some point those can be external Sparkle endpoints. I don't know if that's still true, but if you want to use Sparkle as a API, you can, or should be able to.
Yeah. What was your question?
How do you start VM?
Let's not ask those questions, right now. We can take that offline.
This is an example of some of the control flow type statements. We have, like, if you go back to the social data, not everyone had a spouse listed. So, no, this is for no's. So if the no's column is not empty, you can have it split along the semicolons. For statements, you can also iterate over rows in secondary tables. You can do a variety of things that way. Also the spouse example, if statements to check for empty rows, if not is empty, and then the married to is the call header for that row.
What was the problem you had? You didn't have it within the brackets or something?
Well, yeah. So you have to it has to be valid JSON, but it also has to be valid JSON-LD. So you can't in JSON-LD you can't embed a list within a list. It doesn't really do anything. And so basically the template that this produces has to become JSON-LD. And so, for instance, here, if you have, you can't have, so here the subject is from the at ID, right? And the predicate is schema.org/spouse. The object, if you don't include this, is basically a empty value. And so basically by putting it in a list, you're basically providing an empty list, which means that it will interpret it, if there's nothing in the list, it will just not do anything with that triple. But if you have something in there, it will recognize that it's a triple. And so that's kind of why you need to do that in those cases. So essentially, if you have a @if in there, you need to make sure that the actual JSON-LD that gets generated is going to be valid in both cases. And that's one way. That's the kind of main way to do that.
And then also for the secondary data sources, typically when you're talking, you're defining a data set as a SETL transform, you would include a statement of prop qualified usage using one of the other entities that you extracted, which would be like other tables that you're borrowing to perform your conversion. So you just include them this way. And the using terms identifier JSON-LD here lets you refer to it with that variable. So you can say for row in JSON-LD, we'll go through each, you can iterate through the rows in this other spreadsheet that way.
Right, so you can refer to JSON-LD as a variable that's available in your templates and in your loops and conditionals.
So just to paraphrase, so elsewhere, you created JSON-LD the same way you're creating table. You run table through the thing. And because that exists, you can access it.
Yeah, you have both of them in the extract, two sort of statements in the extract. So you have basically two of those. Maybe one of them comes like for the HBGDki example right now, one of them is a local file and one of them is the URL to a Google Sheet export as CSV. And then you include the qualified usage, so it preserves the provenance of the auxiliary tables as well. And then you can refer to that when you perform the conversion.
So this is super cool. So you can just pull in these reference things and use them in a generation of your RDF, or you smush them together. You could do whatever.
Yeah, you can do basically n by n loop of the things you're expecting and the entities that you have. And that's actually one thing we do for HBGD to say, hey, we know how. So we can say, for instance, we know how to handle time series data in this way. And we know that these other variables are always measured at birth, so we can handle it that way. And essentially just loop through the variables that belong to each other's process and say, is this one in there? No, okay, we'll keep going. This one's in here, okay, we'll do that, we process it that way, and then we loop again through that and filter to say, hey, this is the other usage for these other types of columns. And so, yeah, it's very powerful.
And we can do JSON input now. Can you talk more about that?
Right. So, basically, the main difference between JSON and XML and tabular data is that JSON and XML are both set up to be basically there's one row, and that row is the JSON or XML tree. And so if you're doing any iteration over that, so you can't assume that the top level object in a JSON object or an XML object is going to be a list, or that it's going to have the interesting things you want to iterate over. So what we do is say, well, here's the object, do with it what you think is good. And so you just do the looping from within the template. The other difference is that JSON uses dictionaries, lists, and literals instead of the pandas has its own API for there's the .get to get by string, and then there's you could just do. You saw in some of the other examples, you could just do person.name to directly access things. If it's that simple. In regular dictionaries, it's a little more complicated. You have to use the array access thing. And in XML, we're using the eTree API, so you can do find alls. You can do you can look for attributes. You can iterate over child nodes, and so forth and so on. And then the other nice thing that because we're working with JSON-LD, there's actually some really powerful things going on in JSON-LD. One of them is the named graph support for JSON-LD. At graph can be added to any resource in a JSON-LD document. And that graph is basically a list of resources, same as any other top-level JSON-LD thing. But what you get is a secondary graph that's named for whatever the ID is that you see here. And so you have the ability to generate multiple graphs within the template, and it's basically for free because we're just parsing it as JSON-LD, so it just happens that way. This makes it really powerful to automatically generate, to kind of automatically identify data if you can capture the study ID from the data file itself. So you might have a column for data set ID, and that you can just capture that as part of the graph, and so you know how to stick it. You can generate nano publications really easily because you can basically create a nano publication for every row in data, and it's really up to you about how you format it, how you put together the data. The other thing that's powerful, and I'm not showing it here, although let me. No, the JSON-LD context system is also really, really powerful. And I think I'm going to try to share my screen to show you what I mean by that. I think this is kind of a pretty killer feature. And let's see if I can do this.
So we're at 7 o'clock, so we should.
Okay, so anyway, so if you're at all familiar with the context system in JSON-LD, one of the nice things is that you can say, so I actually put together a JSON-LD context specifically for OWL, so that it makes it simpler to phrase, like much simpler to phrase OWL ontologies in JSON-LD. So when you pair it with this, it becomes really general OWL ontologies. So next. Right, so we are working, so I've implemented XML, but I haven't really tested it, so that's why it's in here, because we haven't had many use cases for it. I also have plans to include HTML scraping using Beautiful Soup. It work very similarly to how the XML, working with an XML document would, except it's more flexible. And I mean, the main thing is that this is work in progress, and we're hoping to move it in useful ways. So go ahead and report bugs or feature requests in GitHub. The one thing that I'd like to note for kind of why this exists is because I'm attempting to move forward a knowledge graph platform called Graphene, that one of the goals is to be able to essentially interpret knowledge from almost anywhere that it can get it. And so one of my goals for SETLr is to make it as kind of flexible as possible in order to capture knowledge from these different kinds of sources.
So Jim, I've got a use case for that, which you may have thought of.
Mm-hmm.
So for one of the projects I'm on, you've got a hierarchy of a file hierarchy that's in an archive. So a file tree, and where some of the knowledge is actually embodied by the levels. The levels of the folders.
Mm-hmm.
So, experimental series, you might have a set of parallel experimental series. You've got, as you move down, you might have a spreadsheet that has some metadata about what's going on. You might have some other folders. So you might have a regular structure as you work your way down, but you also, as you push your way down, you might have different files that have information that can be extracted. So the use cases, there's a couple of aspects that are use case. One is the walking of the tree and knowing when to pull out and then do that class association, that class assignment. It may or may not involve some parsing of the literal to pull out information, because you might have a structured folder name or file name that has information you want to pick up on your way down. But I think you see the problem. You've seen these before. You've got a blob of data that comes in a tarball or whatever, and you just want to zip down, and the structure itself has the semantic information as well as files in that. This, I think, would be that's currently a problem that to attack it, you need to build a separate. To attack it with CSV to RDF, you have to have like a script which does the walking, creates an intermediate form like a CSV that's got the right column structure just to bomb all of this stuff that's discovered, and then you do the actual conversion of that intermediate file. And in fact, you have to do it 2 levels. You have to convert it to sort of the a linked data that represents the file structure, right? And then you've got to do your mapping to your domain ontology to actually end up where you want to get, which is the domain ontology representation, the actual knowledge graph that you're trying to extract. So I think you get it. That would be. I could see where this could potentially do it more directly than the current solution, which is based on CSV to RDF.
Right, and so the thing that I'll need to figure out for something like that is where do we allow the templating, essentially? Because in the case you're talking about, it's almost like we would need to put the template into the SETL part, that basically what we have internal right now itself,
right?
To kind of navigate that sort of thing.
You and I should talk, because this is I think this is a more common than you might think.
Oh no, I think it's very common. I've been guilty of creating those things in the past. So yeah, I know.
Yeah,
it's pretty common.
But it's something that's, I think, subtle that people don't always understand, is that the knowledge is not just in the files. The knowledge is being embodied by the structure.
Right. Can you put in a placeholder ticket for that and describe what you will? And also, it sounds like we're going to need to discuss proposals about how this is going to work.
Yes. Because if we can respond quickly to this, we might be able to slot this into this DARPA project that's going right now. See how fast they did that?
That's one of the reasons that I wanted CSV to RDF for LD and SETLr to think about combining, because the nanomine and the additive manufacturing projects really are likely to intersect. You're talking about the one.
Yeah. Right.
Right, and nanomine is actually one of the projects that we're using SETLr on. We're going to use it to generate the ontology itself, but also to transform a very large and growing collection of annotated XMLs into RDF to use them as an knowledge graph. Basically, each XML becomes a nano population.
The issue with the additive manufacturing is right now there is zero time budget to wait for an augmentation. There's no opportunity right now to pause and say, well, let's wait for SETLr to add this conversion capability. That's the issue. Is there's a strategy right now and a deliverable, and there's a very aggressive set of deliverables that can be accomplished with the current strategy. But that's not to say that, you know, in a month there won't be some time to do this.
Well, the timeline, actually, I was just looking at the end date on it. The timeline is through March, right? I mean, that's what the word says.
Right. But it's unacceptable not to have a strategy in a week for how we do this. You know, that's the work. So I can't change what I'm telling Johnson that, oh, we're going to use SETLr. That doesn't work. We have to say, I have to tell them exactly how we're going to do this. And so, but that's a short term and not necessarily the long term. This may be in the long term.
Well, the additive manufacturing thing, and we hope that this is just specifically like,
right. Right. It's like a lot of these things. You'll prove with this one use case that you can do something, and then we'll give you more, and then you do it the better way. That's all.
So actually the thing to note is that when I generated, I rewrote the HBGDki ontology conversion scripts from CSV to RDF into SETLr as kind of one of the first test cases for SETLr. And
Right.
Writing those conversion scripts in SETLr was actually very fast.
Yeah.
It didn't take long at all. In fact, compared to trying to or experimenting with CSV to RDF and trying to force it to do things that it seemed was unnatural took much longer. So, you know, if you can do it in CSV to RDF, you can probably do it very quickly in SETLr.
Oh yeah, I'm sure. There's some funky time series types of things that Tim was able to do as feats of strength that it would be interesting to see how this does, but I'm sure it handles it fine. Were there any other questions? We're already at 10 after 7.
So when should people other than Katie and Jim use this?
Now, as long as you're willing to suffer the slings and arrows. As long as you're willing to suffer the slings and arrows. I think actually Spencer has tried using it for something. He's using it to generate nano publications.
We should ask Spencer about that. So the request though is that you go to the tutorial, you work your way through the tutorial, you try to work it, and you use you submit issues.
Mm-hmm.
Because the way that the information is going to be more usable is driven by issues.
Right.
And questions.
Right. Like, so right now, SETLr is perfect because I think there are no issues on it.
Yeah, there aren't any issues.
Oh, no, it's just 2 issues.
So Jim, what if you're going to use it on shear?
We are using it in Cheer.
Who's using it?
I'm using it to generate the Cheer ontology right now. And so it can already access LabKey. It can already pull in information from LabKey and transform it into RDF.
Okay, I was just looking at Severe. Are you using it too? Okay. So Jim's the only one using it on Cheer so far. Severe seems like the next candidate, but maybe actually Robin and Jason are sitting here too.
Yeah.
Well, they were. I saw them. They were discussing how they could make use of it. That must have been what they were talking about. How great this would be for our cheer work. I agree, Robin. That's exactly what it would be. Why, yes, Jason. It would be most excellent. So, I think we're all set. If there's no other questions, so let's, thank you very much to these guys. So, a couple of the usual things. Please help clean up consolidating pizzas back there. If there's any left, either take it with you or take it upstairs to the fridge. Sign up for lightning talks. End of the term lightning talks. The link is in the last 3 alert emails about TWeds, including today's. So.
And you guys probably want to make the slides available, or some version of the slides available, or are they already linked off to the wiki page?
They're not linked off the wiki page, but it's like shareable in virtual sheets or virtual slides, so we can put that up somewhere.
Okay.
So thank you very much, Jim.
Thank you.